Perfect. Okay. Well, I think it's working. All right. So, do you have the thing in front of you, or no?
The
Problem set.
yeah.
Okay. So this is the first
Oh,
problem. So basically, this stuff is just like, I don't even know what you call this. Just taking the derivative with respect to different variables, I guess. So this is the first equation, and the first one asks you to take the derivative with respect to x. So like basically whatever variable it's over, that's what you're taking it with respect to. So you treat y as a constant and you treat x like x. So do you have any idea about like what the first derivative would be?
for the equation.
Yeah.
8.
8. Yep.
Just 8 maybe.
So it
Or
starts with 8.
8y.
So 8y, yep. And then what's the rest of it?
Minus 4x minus 2y.
So the 2y is going to go out. So what happens when I take the derivative of this part?
Just kidding. 8x.
8x, yep. And then the 2y is going to disappear. It's just going to be 0 because y is a constant.
Okay.
So it's 8y minus 8x. And then it asks us to plug in 3 and -1 for x and y. So we basically get -8 minus -24. And you get -32.
Hold on, I keep messing up my writing.
No worries.
Is that just the answer?
Yep.
Oh.
So not too bad. So then we're going to do it again. Can I erase this?
Yeah.
Okay. So then we're going to do it again. But we're going to do it with respect to y this time.
Okay.
So basically now we're treating x as a constant and y as a variable. So what does the derivative look like for this one?
So is this one 8x? Does the minus 4x squared stay the same?
So that goes out because it's a constant. So the derivative of a constant is just 0.
Because there's no y with it?
Right.
Okay.
Yep. So, but then this 2y just becomes -2.
Okay.
So that's the derivative for that. And then you plug in the 3 and the -1, but there's no y, so you just plug in the 3, really. And
22.
Yep, perfect. Alrighty. So the next part, it says, it looks like that. So basically you take the derivative with respect to x twice. That's all that means. So the first time we took the derivative with respect to x, what did we get?
8y.
8y minus 8x, right?
Yep.
And then if we were to take it again, what would we get?
8y minus 8.
So
Or is it
if
just
y
minus
is,
8?
Yep, just -8 because y is a constant.
Okay.
And that's it. That's your answer for part C.
Okay. And the first one for the y would be the 8x minus 2.
Good. Yep.
And then the second one would be, is it just minus 2?
So the derivative of 2 is also 0.
Oh, yeah.
Right? So it's just going to be 0.
Am I supposed to show this workout in a specific way?
Mine just looks like, can you see that?
Yeah.
I just wrote like the first and then second. I don't know.
Yeah.
I don't really know what work there is to show for it.
Yeah.
So now this one is f of x and then of y. So the first one for x was 8y minus x. And then if we were to do it for y, what would we get?
Wait, can you sorry, I was missing. What did you say to do?
Yeah, so this was this means that you take it in respect to x and then in respect to y. So the first derivative, when we took it with respect to x, this is what we got, right? So then we
Okay.
take it with respect to y, and what do we get?
8x minus 2.
Just 8, right? Because like if we take this with respect to y.
Oh.
Okay. So yeah, so you take like the answer and then you take the derivative of the answer.
Respect. Okay.
Are you good with that?
Yeah.
Okay.
So that answer's just 8?
Yep. Are you good with that one?
Yep.
Okay, cool. Alrighty. So for the next one, we have f of x comma y equals 4e to the x squared y cubed. So same process for this one. So the first question is to do it with respect to x. So this is like an e to the u kind of thing.
Oh god.
So for these ones, the derivative is like u e to the, nope, that's not even right. Just, I didn't say that. Okay, oh my goodness. Okay, so for these ones, it's e to the u times du, right?
Okay.
So we keep the same because that's the e to the u for x squared, that's a y. Okay, and then what is the derivative of u with respect to x?
Um, this 2x 3y squared.
So it's just going to be 2x y cubed, right? Because y cubed is a constant. So if we were taking it with respect to y, then it would be 3y squared. But it's just a constant, so we're just going to leave it as it is.
So that's all it is.
Yep, that's your answer. Are you good, or?
Yeah.
It's just like, it's easier than it looks. It's just like hard to, I don't know, to look at y or x and just call it a constant. All right, so then the next part is to do the same thing, but with respect to y. So we're going to start off with the same thing because it's still an e to the u. And just what we multiply is going to be the different part. So we're taking the derivative of this part with respect to y now.
So would it just be x squared 3y squared?
Yep, good. See, you got this, girl. You know what
Yeah, I
you're
just
doing.
can't follow along with him, so I just.
I know. He's very difficult, but you know what you're doing, though.
So then that's it for that one too, right?
Yep.
Okay.
Alrighty, so number 3. I'm really glad these are super short because I don't like math.
I don't know. Are you gonna go to the class tomorrow? Because I said it's optional.
I don't think so. Because we already have this done. What the heck is the point? Alright, so this is this one. So this is like, I don't even remember what this is called. Integration by parts? Who even knows? It's that inner and outer thing. So we basically take, we always work inside out. So this is the whole first integral is like the first sign, like the squiggly sign, and then whatever comes first, dx, dy, and then the whole equation. So if we were to look at this one, it would be the integral of 0 to 1 of xy squared dx. And since it's dx, we're going to integrate with respect to x, so y is going to be a constant. So what can you do to the y since it's a constant? You can take it out, right? We can always take out constants of integrals. So it just makes it a little bit easier for us to look at. So you can just pull the y squared right out. And then how do you integrate x?
X squared over 2.
Yep. So x squared over 2, and it's going to be times y squared. Sorry, we're getting real tight over here. And it's going to be evaluated from 0 to 1. So when you plug in 1, wait, yes, we're doing good. Okay. When you plug in 1 to x squared over 2, what do you get?
1/2.
Yep. And then when you plug in 0, you get 0. So 1/2 minus 0 is 1/2, and then it's still going to be multiplied by the y over 2. So basically, we're going to get y squared over 2 as the answer to the inside integral.
Okay.
Now for the outside integral, we're basically going to take that y squared over 2 and integrate it with respect to y this time. So it was 1 to 4, and then it's going to be y squared over 2 dy. And so how do you integrate y squared over 2?
Y to the third over 6.
Good. So that's good. We're going to evaluate it from 1 to 4. Okay. So if you plug in 4 and cube it, you're going to get 64 over 6. If you plug in 1, you're going to get 1 over 6. You basically get 63/6 or 10.5. And that's your answer to the whole problem.
So 10.5 is your whole answer?
Yep.
Okay. Okay.
Alrighty, good with this one?
Yep.
All right, only one more. Cruising through these.
Yeah.
So let's see. This one is the same type of deal. Those are zeros.
Yeah. So we do the 2, 0. So we just do the 16 minus x squared minus 2y squared dx first.
Yep. So we're going to do this. Oh, that's an integral, and it's 0 to 2. So how do you integrate this? If y is a constant.
Is it the minus x squared plus 16? Oh, shoot.
So let's take it term by term. So what's the integral of 16?
Oh, 0. Wait.
That's the derivative.
16x.
16x, good. And then what about for negative x squared?
Minus 2x.
That's the derivative.
Oh my god. Oh, hold on. Minus x to the third over, okay.
Right?
Yeah.
And then if we were to do 2y squared, it's a constant like 16. So we can just put an x attached to it, right? Because it's just a number.
Okay.
You good with that?
Yeah, I think so.
Okay. So it's evaluated from 2 to 0. Well, 0 to 2. So what happens when we plug in 2?
You get 32.
Good.
8/3.
Yep.
And then it's just minus 2y squared, or minus 4y squared.
Good. Minus 4y squared. Yep. All right, and then this 32 minus 8/3, if you want to combine that into one thing, it's just going to be 88/3.
Okay.
And then minus 4y squared. You good with this part?
Yep.
All right, so now we're going to do that. We're going to integrate it again with respect to y this time. So the integral is still 0 to 2. And now we have 88/3 minus 4y squared dy.
Minus 4y squared, you said?
Yeah, sorry.
Okay.
So how do you integrate 88/3?
Is
It's
this,
just a number.
I don't know, I'm tripping up.
How do you integrate 16? How do we do that?
Oh, 16x.
All right, so it's just going to be 88/3y this time, though, right? Because we're integrating with respect to y.
Oh, okay.
Okay.
Yeah.
And then for the 4y squared, what are you going to do with that?
Just the, oh, sorry, 1 sec.
Okay.
4y cubed over 3.
Good. And then we're going to evaluate it from 0 to 2. So if you plug in 2, you get 176/3 minus 32/3. And if you were to plug in 0, it would just be 0 for all the terms, so that doesn't really matter. And then you would get 144/3, which is equal to 48. And that is your answer.
That wasn't too bad.
That's it. Pretty good.
Oh, thank you so much.
You're very welcome. Hopefully this recording works. Not really sure how to do that, but it's fine. I'll just have another meeting with Chloe if it doesn't work.
Yeah, that was quick anyways.
Yes, it was. Alrighty.
Thank you.
I shall talk to you soon.
Yes, bye.
Bye.